That last one is a blooper reel. So this is actually f prime of x. Okay, a horizontal tangent on f prime of x would mean that's where f double prime is equal to 0. F double prime equals 0. But we want horizontal tangents about f of x. So it's not negative 4, 1, and 0. Where would f of x have a horizontal tangent? Right, it's where f prime is equal to 0. That's where f has horizontal tangents, would be at negative 2 and positive 3. F has horizontal tangents there. Okay. Now the tricky part is we need a little bit of room here, so I'm going to use this space right down here. And I want to find out where f has inflection points, but also before that we're going to find out where f has a max or a min. I like to do an f prime test because I can see f prime right smack dab in front of me. Negative 2, 3, and 4. So what did I put? Along this f prime test, I'm showing where we have an endpoint of the interval of the domain, another endpoint of the domain, but then over here at negative 2 and 3, this is where we have our critical points, where f prime is equal to 0. Okay? Well, on the interval from negative 5 to negative 2, we can see clearly that f prime is positive because f prime is above the x-axis. In between negative 2 and 3, we see that f prime is below the x-axis, so f prime is negative. And between 3 and 4, we see that f prime is above the x-axis, so f prime is positive there. That being said, what do we know about f? Guess what? F is doing what between negative 5 and negative 2? Increasing, and then decreasing, and then increasing. So we can see the intervals. F is increasing on the interval here from negative 5 to negative 2, decreasing from negative 2 to 3, and increasing from 3 to 4. Okay? Well, that means that we have a local max here, and we have a local min here. But what do we have at negative 5? We have a min. And what do we have at 4? We have a max. We have a max at 4 because it's an endpoint. The graph of f goes up from left to right, all the way up to 1 till when x is equal to 4. So now concave up and down. So let's look at f double prime. F double prime is we already said where f double prime is equal to 0. So let's do the f double prime test. Let's do that over here. Let's move this over. Again, if you miss anything, this will be in a video. So f double prime test, we see the critical points for f double prime are where f double prime is equal to 0. And that happens when x is equal to negative 4. Let's not forget about negative 5 as an endpoint. F double prime is equal to 0 at 0. Also at 1. And then f double prime, the endpoint would be at x equals 4. So the slope of the f prime is what we're looking for. Okay, slope of f prime, because that gives us the f double prime sign. Okay, what's the slope? Is it positive or negative from negative 5 to negative 4? It's positive, right. The slope of f prime is positive there. And then the slope of f prime between negative 4 and 0 is negative. Slope of f prime between 0 and 1 is negative. And then positive to the right. Okay, that means that f is concave up or down from negative 5 to negative 4, up, and then concave down, then concave down, and then concave up. So how many inflection points do we have? We have inflection points at x equals, when you change concavity from up to down, at x equals negative 4, and also, so it's normal for students to pick 0 as an inflection point, but why is it not? Because you don't change concavity, you go from down to down. You only get an inflection point when you go concave down to up or up to down. That occurs at 1. So we have inflection points there, negative 4 and 1. And absolute max or min. We don't have an absolute max or min because the graph looks like this from negative 5 to 4, you're not really sure where the absolute max or min is, but that would be what the graph would look like, of f would look like between negative 5 and positive 4. So I don't know on the absolute max or absolute min on the interval from negative 5 all the way to 4. However, I'm taking time on this because I put a little box over there that says on the interval from negative 5 to positive 3 now, let's look at that. We have negative 5, negative 2, same thing we just did, to positive 3. That's our other endpoint. Plus, 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 minus, 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 plus, minus. What do we know we have on the interval from negative 5 to 3? We have an absolute max at where? At x equals negative 2. Again, on the interval though from negative 5 to 3, we do know that we have an absolute max. That makes sense? Okay. So sometimes we can find that, sometimes we can't. So there you go. I think that's about it. Did I miss anything? Now's your chance to get on the video. Okay, everybody say goodbye.
Shout out to my boy.
Louder. Say goodbye louder.
Adios, senor.
That's it? That's all you guys have? Nothing. That's all you
Shout
have.
out to the